This man helped create modern artificial intelligence. He was one of the researchers behind AlexNet, the breakthrough that changed AI forever. He helped pioneer the ideas that would later become the foundations of GPT. And he was one of the key scientists behind OpenAI and ChatGPT. For years, his entire career was focused on one objective: making machines smarter. But then something changed. As AI became more powerful, Ilya Sutskever started asking a different question.
What is the problem of AI and AGI? The whole problem is the power. When the power is really big, what's going to happen?
Most people saw ChatGPT as a technological miracle. Ilya saw something else. A future that was approaching much faster than anyone expected. A future where machines might eventually become smarter than humans themselves. And in 2023, he did something that shocked the entire technology industry. He turned against Sam Altman, the CEO of OpenAI, the company he had spent years helping build.
And if Ilya felt strongly enough to want to, fire Sam, well, I think the world should know what was that reason.
To this day, nobody outside a small group of people know exactly what happened. But one thing is certain: the closer artificial intelligence got to working, the more concerned some of its creators became.
There is also a longer-term existential threat that will arise when we create digital beings that are more intelligent than ourselves. We have no idea whether we can stay in control.
This is the story of the man who helped build modern AI and why he became afraid of what might come next. Before becoming one of the most important minds in artificial intelligence, Ilya Sutskever spent his early life moving across completely different worlds. He was born in the Soviet Union in 1985 into a Jewish family, but his stay there didn't last long. The Soviet Union was already beginning to collapse, and just a few years later, his family left the country, moving to Israel in search of a new life. So Ilya grew up in Jerusalem during the 1990s. From an early age, he showed an unusual talent for abstract thinking, especially mathematics. But more than anything else, he became obsessed with one question: how does intelligence actually work?
And when I was a teenager, an early teenager in the late 90s, the sense that I got is that science simply did not know how intelligence worked.
That idea fascinated him. How does the brain recognize patterns? How does memory work? How do neurons communicate with each other? At a time when most teenagers were thinking about normal life, Ilya was becoming obsessed with the mechanics of intelligence itself. But it wasn't in Jerusalem where he would find the answer to those questions. While still in high school, his family moved once again, this time to Toronto, Canada. And almost immediately it became clear that Ilya wasn't a normal student. According to multiple accounts, he attended high school in Canada for only about a month before being admitted directly into the University of Toronto, where he enrolled in computer science. And it was there that he would meet the person who would completely change the course of his life, the professor Geoffrey Hinton. Today, Hinton is considered one of the most influential figures in the history of artificial intelligence. He is often referred to the godfather of AI. He is the winner of the Turing Award in 2018, an award often referred as the Nobel Prize of Computer Science, and later the Nobel Prize in Physics in 2024. But when Ilya first encountered him, the story looked very different. Geoffrey Hinton at the time was just a professor at the Faculty of Computer Science. For years, Hinton had been working on neural networks, computational systems inspired by the human brain. But by the early 2000s, much of the AI world had already started moving away from them. Many researchers at the time believed neural networks had reached a dead end. They were considered too slow and too computationally expensive to ever become the future of artificial intelligence, but Ilya was determined to know more about it.
I was in my office, probably on a Sunday, and there was a knock on the door. Not just any knock, but it went kind of a sort of urgent knock. So I went and answered the door, and this was this young student there. And he said he was cooking fries over the summer, but he'd rather be working in my lab. And so I said, well, why don't you make an appointment and we'll talk? And so Ilya said, how about now? And that sort of was Ilya's character.
So Ilya started working in Hinton's lab, developing and studying neural networks. But what exactly were Hinton and Ilya working on? At the time, much of AI research was focused on building systems by explicitly encoding knowledge into them, designing digital intelligence through rules, instructions, and uncrafted representations of the world. But the Hinton team were interested into something very different. They were trying to answer another question: how can a machine learn by itself? Opposite to the other AI researchers, Hinton and Ilya weren't trying to program knowledge. They were trying to program learning instead, and conceptually to make the intelligence grow by itself. To understand this idea, let's look at a simple example. Imagine you are trying to teach a computer what a cat is. At the time, most AI systems approach this problem by manually writing rules. A researcher might tell the machine, cats have pointed ears, cats have whiskers, cats have a certain face shape. In other words, humans had to explicitly define the characteristics the machine should look for, shaping their knowledge so their intelligence. And that worked, until reality became really messy. Because what happens if the cat is partially hidden? What if it's dark? What if it's looking sideways? Suddenly you don't need dozens of rules anymore. You need thousands, maybe millions. And Hinton believed there was a completely different approach. Instead of telling a machine what a cat looks like, what if you simply showed it millions of cat pictures and allowed it to learn patterns on its own? And that was the core idea behind neural networks, not teaching machines what to think, but teaching them how to learn.
I got into AI pretty early. I was very interested in math and brains and what am I? And I'm a computer, how can that be? That's very strange. So AI was very interesting, and within that, machine learning specifically was the really mysterious thing, because in math you got the logic, the deduction, but how can you know that the sun's gonna rise tomorrow? What's the basis for that?
After years of research in Hinton's lab, Ilya had developed an intuition that few people shared. Neural networks could become far more powerful than anyone imagined, if they were trained with enough data and enough computing power.
Ilya got that intuition very early. So Ilya was always preaching that you just make it bigger and it'll work better. And I always thought that was a bit of a cop-out, that you're going to have new ideas too. It turns out Ilya was basically right, but it was really the scale of the data and the scale of the computation.
For the first time, there was a massive convergence of two things: data and computing power. Powerful GPUs, originally designed for gaming, were becoming available, making it possible to train much larger neural networks. And at the same time, the internet was creating an explosion of data. Suddenly, datasets were becoming bigger than anything researchers had ever seen before. And among them, one database stood above everything else: ImageNet. At the time, the biggest image dataset available was Pascal, and Pascal contained only a limited number of categories and a relatively small amount of data. ImageNet was on a completely different scale, more than 1 million labeled images across 1,000 different categories: dogs, cars, buildings, animals. It wasn't just another dataset, it was the biggest dataset of images ever existed. And around this dataset there was a competition. Teams of researchers were competing to build a system that could recognize what was inside an image more precisely than anyone else. The ImageNet competition was the ultimate battleground that every serious AI researcher wanted to win, because success on ImageNet meant demonstrating that your approach could solve real-world problems.
So I remember Ilya coming into the lab one day and saying, look, now that we've got speech recognition working, this stuff really works, we've got to do ImageNet before anybody else does.
Ilya immediately saw an opportunity that most researchers overlooked. For the first time, the world had two ingredients neural networks had always been missing: massive amounts of data and unprecedented computing power. Now, for the first time, it was possible to test a radical idea: train a huge neural network directly on raw images and let it learn on its own. So he convinced AlexNet, another researcher in Hinton's lab, to attempt something almost nobody believed could work. Train a massive neural network on the largest image dataset ever assembled, in only a few months and with extremely limited computational resources. Alex accepts, and with Ilya and Hinton, they start working deeply into this challenge. The deadline was there, October 2012, Florence, Italy. The day of competition finally arrived, and the ImageNet results were about to be revealed. People took seat to witness with interest the result of this different approach. Then the numbers appeared. Second place, 26.2% error rate, then supervision, the Toronto's team submission, 15.3%. For a moment, people thought something had to be wrong, because the improvements in ImageNet usually happened gradually, fractions of a percent, 1 point maybe, not 10. They hadn't won, they had destroyed the competition.
And with ImageNet, all the ingredients were there. Alex had these very fast convolutional kernels. ImageNet had the large enough data, and there was a real opportunity to do something totally unprecedented, and it totally worked out.
This was the proof machines could learn representation themselves. Within months, labs across the world started abandoning traditional computer vision pipelines. By 2014, almost everyone did. The field had pivoted overnight.
What's going on here? Is AlexNet a breakthrough in computer vision, or is this a bigger idea than that? And we came to the conclusion that what AlexNet and deep learning showed is that it is now finally possible, if we had enough data, enough computing scale, we might be able to apply computers to solve problems that were impossible to describe using human engineered features.
After AlexNet, something became clear almost immediately. This wasn't just a better image recognition system, it looked like the beginning of something much deeper, and Google noticed it. Because by 2013, a new race had quietly started inside Silicon Valley. The question was no longer, can deep learning work? They had just been answered with AlexNet. The new question became, if this technology is real, who is going to control it? Google already had something almost nobody else had: billions of search queries, YouTube, massive data centers. But they were missing something far more important: the people building the future of AI. Only a few months after AlexNet, Google acquired DNN Research, the small company created around Geoffrey Hinton and his team. And suddenly, Ilya's world changed completely. Just months earlier, he had been working inside a university lab with limited resources and only a handful of GPUs. Now he had access to something almost no researchers on Earth had: Google. Inside Google Brain, Ilya started working alongside some of the most talented researchers in machine learning. But interestingly, he wasn't focused on building products. He was focused on a much bigger question. AlexNet had just shown that neural networks could learn how to see, understand patterns inside images. But what if they could learn much more than images? Because the world isn't made only of pictures, it's also made of words in a sentence, sounds in a conversation, questions and answers. And unlike images, words and language were considered an incredibly difficult problem. Because words alone don't carry meaning. Meaning emerges from the way words are combined, the context they appear in, and the sequence in which they are used. So Ilya started exploring a new idea: Could a neural network do with language what AlexNet had done with images? Could it learn the patterns hidden inside words and sentences? For example, translate a sentence from French into English, read a question and generate an answer. In other words, could a neural network learn to transform one sequence of information into another? This idea would later become known as sequence-to-sequence learning. At the time, it looked like just another research paper, but hidden inside was something much bigger. For Ilya, this raised an intriguing possibility. Perhaps neural networks weren't limited to recognizing objects anymore. Perhaps they could learn how to work with language as well, and words could describe almost anything. By 2015, Ilya Sutskever was exactly where many AI researchers dream of being. He was at Google, the place that had basically become the center of the AI universe.
I was a researcher at Google, and I was working on deep learning, and I was having a lot of fun. I was really enjoying my time at Google.
He had computing power. He had some of the smartest researchers on Earth around him, so there was absolutely no reasons to leave. Except for one thing. Ilya had begun thinking about where AI was heading. Not just the next model, something much bigger.
And then one day, basically, so kind of picture this, here I am, daydreaming. Like it was daydreaming that maybe I could start an AI company, but it really wasn't clear how I would do it. How would you possibly get the money for such a thing? Those things would be expensive.
And while these ideas were growing in his mind, something completely unexpected happened. One day, an email arrived from Sam Altman, and it wasn't some elaborate proposal. It was actually very simple.
And then actually one day, I received a cold email from Sam saying, hey, let's hang out with some cool people. And I was very curious, I went.
Ilya went, and sitting there at the table were Sam Altman, Greg Brockman, and Elon Musk. At the time, Elon Musk was already becoming famous for Tesla and SpaceX. Sam Altman was running Y Combinator. Greg Brockman had recently left Stripe.
So of course I went. And here I was at a dinner and they were discussing how could you start a new AI lab which would be a competitor to Google and to DeepMind, which back then had absolute dominance.
Compete with Google, compete with DeepMind. At the time, that sounded insane, and even Elon Musk thought so.
In the beginning, I thought, look, this is probably a hopeless endeavor. How could we possibly compete with? How could OpenAI possibly compete with Google DeepMind? I mean, this seemed like an ant against an elephant.
But Elon Musk also knew something else. If they wanted even a tiny chance, they needed Ilya, because he was one of the very few people in the world who actually knew how to build frontier AI systems.
Was instrumental in recruiting the key scientists and engineers, most notably Ilya Sutskever. He would say he's going to join OpenAI, then Demis would convince him not to, then I would convince him to do so. And then
the Misasabis from DeepMind on one side and Elon Musk at the other, two of the biggest names in AI, tried to convince one person, because everyone understood the same thing. If OpenAI got Ilya, OpenAI could suddenly become real.
I asked Sam, okay, how do we break symmetry here? How do we actually get everyone to say, all right, we're joining?
So Altman came up with an unusual idea. Take everyone away for a few days, Napa Valley, no contracts, no organizational charts, just researchers and ideas. And there, something changed.
Right? And you think about what could happen if we could really build systems that are able to work with people on solving the most complicated multidisciplinary challenges that humanity has to face today.
Engaged by the core values and missions presented, many of them decided to come on board. For Ilya, this meant making one of the biggest decisions of his life. He resigned from Google and joined OpenAI in 2015. But because OpenAI was offering something different, the opportunity to pursue what he believed was the next frontier of artificial intelligence, artificial general intelligence.
But at OpenAI, we took the liberty to look at the big picture. We asked ourselves, okay, where is AI going towards? And the answer is AI is going towards AGI, towards an AI which eventually is as smart or smarter than a human in every way.
That was the original vision of OpenAI, build AGI, and they wanted to build it before anyone else did. But they also believed something equally important, that it had to be built safely, because if intelligence became humanity's most powerful technology, whoever controlled it could shape everything that came after. So, starting from day zero, OpenAI had one mission: build AGI. The problem was, nobody actually knew how to get there. So during the early years, OpenAI tried almost everything. Robotics, games, reinforcement learning. Different paths toward intelligence. Because if the goal was building AGI, the path was still completely unknown. But while many researchers were exploring different directions, Ilya kept returning to one idea. Maybe intelligence wasn't something you manually build. Maybe intelligence can emerge.
Just before OpenAI started, I met Ilya. One of the first things he said to me was, look, the models, they just want to learn. You have to understand this. The models, they just want to learn. You get the obstacles out of their way, right? You give them good data. You give them enough space to operate in. You don't do something stupid like condition them badly numerically. And they want to learn. They'll do it.
At first, this almost sounds philosophical. The models just want to learn. But hidden inside that sentence was a radical idea. Imagine teaching a child. You don't explain every possible situation they will face in life. You don't write thousands of rules. Instead, you expose them to books, conversations, experiences, patterns, and slowly they begin understanding the world. So Ilya started asking a strange question. What if we did the same thing with AI? What if you gave it only one objective? Predict what comes next.
Ilya Sutskever once said a very simple sentence that, as many simple sentences he said, it really stuck in my mind, which is prediction is very close to intelligence. And the idea is that if you can compress all of the information about the world, the state of things, whatever, into its smallest representation, and then as part of that predict the thing that's going to happen next, you understand it in a sort of deep way.
Because to predict the next word extremely well, you can't simply memorize words. You need to understand facts, relationship, patterns, human behavior, how the word itself works. The best approximation possible of human intelligence. And yet, inside OpenAI, this idea started becoming increasingly important. So they start applying this concept to real models, and the results were promising. They kept improving again and again. This wasn't random anymore. Every time they increased more compute, more data, larger models, the systems kept improving.
So you say, hey, if you mix some compute with some data into a neural net of a certain size, you will get results, and you will know that it will be better if you just scale the recipe up.
What had started as an experiment became a strategy. Scaling. One word, but a word that starts changing the entire AI industry.
Then the scaling insight arrived, right? Scaling laws, GPT-3, and suddenly everyone realized we should scale. And it's just this is an example of how language affects thought. Scaling is just one word, but it's such a powerful word because it informs people what to do. They say, okay, let's try to scale things.
And very quickly a race started. Across Silicon Valley and the entire research community, everyone suddenly wanted more data, more GPUs, bigger models. And in the meanwhile, OpenAI kept moving forward. GPT-1, GPT-2, GPT-3. Each model larger than the previous one, each one trained on more data, each one becoming increasingly capable. But then, something unexpected started happening. The systems weren't simply becoming better, they started doing things nobody explicitly told them. writing stories, summarizing information, generating code, answering questions, almost as if new abilities were appearing naturally on their own. And that was the moment people inside OpenAI started realizing this wasn't normal anymore. What they created was way more capable of what most expected. And by late 2022, they faced a very unusual decision. For years, their models had lived mostly inside research papers and internal experiments. Now that's something different, a model that people could actually use. But there was a problem. Nobody really knew what would happen if they put a system like this direct into the hands of the public. The technology was improving so quickly that even the people building it didn't fully understand where it might lead.
But as soon as it gets really complicated, we don't actually know what's going on any more than we know what's going on in your brain.
What do you mean we don't know exactly how it works? It was designed by people.
No, it wasn't. What we did was we designed the learning algorithm. That's a bit like designing the principle of evolution. But when this learning algorithm then interacts with data, it produces complicated neural networks that are good at doing things, but we don't really understand exactly how they do those things.
Still, inside OpenAI there was another belief emerging. You couldn't understand systems this powerful by keeping them locked inside a laboratory. You had to see how the real world would interact with them. So rather than waiting for perfection, they decided to release it as a research preview. Not to researchers or scientists, to everyone. And on November 30, 2022, they pressed the button.
Very creepy. A new artificial intelligence tool is going viral for cranking out entire essays in a matter of seconds.
And it's called ChatGPT.
Within 5 days, 1 million users was accessing ChatGPT. Within 2 months, 100 million users, the fastest growing consumer application in history. Students, writers, programmers, companies, everyone was trying it. The internet started losing its mind.
ChatGPT. Maybe you've heard of it. If you haven't, then get ready, because this promises to be the viral sensation that could completely reset how we do things.
The thing Ilya had spent years helping build was now becoming one of the most impactful technologies on planet Earth. By the end of 2023, OpenAI had become one of the most important companies on Earth. Less than a year earlier, ChatGPT had barely existed. Now, hundreds of millions of people were using AI. And at the center of it all was Sam Altman. To the public, he had become the face of artificial intelligence, the man leading humanity into the next era. But inside OpenAI, something was changing. Because while the company was growing faster than anyone imagined, the debates around safety weren't disappearing. They were becoming more intense, and nobody was thinking more deeply about those questions than Ilya Sutskever.
I do think one of the many things that I really love about Ilya is he takes AGI and the safety concerns, broadly speaking, including things like the impact this is going to have on society, very seriously. Ilya is one of the people that I've spent the most time over the last couple of years talking about what this is going to mean.
For years, Sam and Ilya had worked side by side, one pushing the organization forward, the other helping define the science behind it. Together, they had transformed OpenAI from a small non-profit into the most important AI company in the world. But now, the same success that brought them together seemed to be pulling them apart. November 17, 2023. Apparently a day like another, at least from the outside. Behind closed doors, the board had been having conversation for weeks. Conversation nobody knew about. Not employees, not investors, not even Microsoft. Then suddenly everything changed.
The tech world has been thrown into chaos over the weekend when the company that gave us ChatGPT fired its CEO. Sam Altman, who has drawn comparisons to tech giants like Steve Jobs, was dismissed by the OpenAI board Friday.
The entire Silicon Valley was stunned. Employees and investors were stunned. Even the people closest to OpenAI struggled to understand what had happened. And among the people who supported the decision was Ilya Sutskever himself.
I'm particularly proud of the fact that one of my students fired Sam Altman.
The same person who had spent nearly a decade building OpenAI alongside Sam. Nobody knew what to make of it. Why would Ilya do this? What could possibly justify removing the CEO of the fast and growing technology company in the world? The theories started immediately. Safety, power, governance, AGI, nobody knew.
I think we should be concerned about this because I think Ilya actually has a strong moral compass. He thinks about, he really sweats it over questions of what is right. And if Ilya felt strongly enough to want to, fire Sam, well, I think the world should know what was that reason.
Even Elon Musk was searching for answers. Had OpenAI discovered something? Had Ilya seen something that worried him?
Either it was a serious thing, and we should know what it is, or it was not a serious thing, and then the board should resign.
To this day, Ilya Sutskever has never publicly explained why he voted to remove Sam Altman. The official explanation focused on governance and a breakdown of trust between the board and Altman. But many people inside the AI community suspected something deeper. Questions about whether OpenAI was moving too fast.
So OpenAI was set up with a big emphasis on safety. Its primary objective was to develop artificial general intelligence and ensure that it was safe. One of my former students, Ilya Sutskever, was the chief scientist. And over time, it turned out that Sam Altman was much less concerned with safety than with profits. And I think that's unfortunate.
For a few chaotic days, OpenAI descended into crisis. Then something unexpected happened again. Ilya changed his mind. Sam Altman returned, and the company moved forward, at least on the surface, because only a few months later, Ilya himself would leave OpenAI. And when he finally revealed what he wanted to build next, it became clear that the real story was never about Sam Altman. It was about something much bigger, the possibility that artificial intelligence might actually work. A few months after the OpenAI crisis, Ilya Sutskever left. For many people, it didn't make sense. OpenAI had won, ChatGPT had conquered the world. The company was worth billions, so why leave? To understand that, we need to understand what Ilya believed was coming next.
Slowly but surely, or maybe not so slowly, AI will keep getting better. And the day will come when AI will do all the things that we can do. Not just some of them, but all of them.
For most people, AI was a chatbot, a productivity tool, a better search engine. But Ilya wasn't thinking about ChatGPT. He was thinking about what comes after. Because if intelligence can be scaled, then eventually this system may become capable of performing every intellectual task a human can perform. And once you believe that, a completely different question appears.
What is the problem of AI and AGI? The whole problem is the power. When the power is really big, what's going to happen?
The concern was what happens when intelligence becomes powerful. Because for the first time, the technology itself may become capable of making decisions. And even the people building it admit something uncomfortable. They don't fully understand how it works.
There is also a longer-term existential threat that will arise when we create digital beings that are more intelligent than ourselves. We have no idea whether we can stay in control.
For decades, this sounded like science fiction. Now it was being discussed by the very few people who created the technology. And according to Hinton, there was another reason to worry.
But we now have evidence that if they are created by companies motivated by short-term profits, our safety will not be the top priority.
This idea was becoming increasingly difficult to ignore, because after ChatGPT, AI wasn't just a scientific project anymore. It had become a race. Companies were raising billions, the incentives were changing, and Ilya believed something else would happen.
I also maintain that as AI continues to become more powerful, more visibly powerful, there will also be a desire from governments and the public to do something. I do think that at some point the AI will start to feel powerful, actually. And I think when that happens, we will see a big change in the way all AI companies approach safety. They'll become much more paranoid.
In other words, right now people still focus on what AI gets wrong, the mistakes, the hallucinations, the failures, but Ilya believed that one day the conversation would change. If superintelligence was coming anyway, someone needed to focus entirely on making it safe. So in June 2024, he started over.
Another eye-popping valuation for a brand new AI startup. This time it's OpenAI's former chief scientist raising a whopping $1 billion for his own company, Safe Superintelligence, Inc.
A few weeks after leaving OpenAI, Ilya revealed what he had been working on, a new company called Safe Superintelligence, or simply SSI. He founded it together with Daniel Gross, a successful entrepreneur and AI investor, and Daniel Levy, a researcher who had previously worked alongside him at OpenAI. But what made SSI different wasn't the team, it was the mission. Because unlike OpenAI, unlike Anthropic, and unlike virtually every major AI company in the world, SSI wasn't trying to build a chatbot. In fact, the company explicitly stated that they had no intention of balancing research with commercial pressures. No consumer applications, no race for users, no product roadmap. Only one objective: build a superintelligence and make sure it is safe. For Ilya, that distinction was crucial, because he believed that once a company starts competing for customers, revenue, and growth, it inevitably faces pressure to move faster, to release products, to prioritize short-term goals. SSI was designed to avoid that conflict entirely. Its singular focus would be research, nothing else. Investors immediately paid attention. Despite having no public product, no revenue, and just 10 employees, SSI quickly reached a multi-billion-dollar valuation, not because of what he had built, but because who was building it. Many investors believed that if anyone understood where artificial intelligence was heading, it was one of the people who helped create GPT in the first place.
SSI has raised $3 billion. That's what you could say, but look at the other companies raising much more. But a lot of their compute goes for inference. Like these big numbers, these big loans, it's earmarked for inference. You need, if you want to have a product on which you do inference, you need to have a big staff of engineers, of salespeople. A lot of the research needs to be dedicated for producing all kinds of product-related features. So then when you look at what's actually left for research, the difference becomes a lot smaller. We have sufficient compute to prove, to convince ourselves and anyone else that what we're doing is correct.
Companies like OpenAI, Google, or Anthropic must divide their resources between research, products, infrastructure, and serving millions of users. SSI has only one goal: research. Every dollar, every GPU, every researcher focus on a single problem: how to build a safe superintelligence. In Ilya's view, that focus allows SSI to remain competitive despite being much smaller than its rivals, because they are not trying to do everything, they are trying to solve one problem exceptionally well. The story of Ilya Sutskever began with a student fascinated by neural networks. It helped create AlexNet, GPT, ChatGPT, and the modern AI revolution. But today, his mission is different. Not making AI more powerful, making sure that when it becomes powerful enough, humanity remains in control. Because perhaps the most important question in artificial intelligence is no longer how do we build it, but what happens if it actually works. And with that, we've reached the end of this video. If you found it interesting, leave a like and subscribe to the channel. Until next time, from Vision Economy.